Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Dynamic Domino Sums by Jolly Rogers. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. The grid is partially covered in fog. Correctly placed digits will clear fog in that cell and sometimes other cell. No guessing is required. So this is dynamic fog of war. So if you placed a digit correctly, say, in that cell, it would clear the fog just in that cell and potentially other cells around it. But we're guaranteed that it would clear the fog in this cell. And I like this type of dynamic fog of war. Also, we need to divide the grid into non-overlapping dominoes. Every cell in the grid belongs to a domino apart from the given digit in the red cage. So, aside from this digit, every cell must be part of a domino. So it must be part, like, this could be part of that, this could be part of that, and it has to be part of one and only one domino. So you cannot have overlapping dominoes like this or something along those lines. Okay, so yeah, every cell in the grid belongs to a domino apart from the given digit in the red cage. So this one is not part of a domino. The sum of a domino's digits indicates how many dominoes in the grid share that sum. For example, if a domino sums to 10, there must be 10 dominoes with the sum of 10. Interesting. So, for example, say we had a 4 and a 6 in this domino. Then that would require that there are 10 other dominoes which also add up to 10. And same for 11, same for 12, etc., etc. We have domino borders divide each blue line into segments of equal sum. So we see, I don't know if this line continues, but say we had, say this line basically was just to here. If we had, say, a domino here, and a domino here, this domino border would divide this domino, this line into segments of equal sum. So these two would have to add up to that digit if that were the case. We also have, say it extended farther, right? Say it extended like that. And say we had a domino here, and a domino here. Then the sum of these two digits would equal the sum of these two digits, which would equal the sum of that digit there. And that would be an example of how domino borders work. Well, actually, that's how this is essentially a region sum line. Or I guess these would be a domino sum line? I don't know. I'm not sure what we'd name it. But that's an example of how that would work. Also, we have digits joined by a black dot must be in a 2-to-1 ratio, and not all possible dots are given. So, for example, if this were, say, a 4, this would have to be a 2 or an 8, because this would have to be a 1 to 2. This would have to maintain a 1 to 2 ratio between these digits. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, first things first, we have in row 9, 6 digits, which are in a 1 to 2 ratio, each with another unique digit. So it must be the digits 1, 2, 3, 4, 6, and 7, 8. Sorry, 1, 2, 3, 4, 6, and 8. 4 has to be with 8. 3 has to be 6, 1 has to be with 2, but we don't know which one's which. So we have 1, 2, 3, 4, 6, 8. 1, 2, 3, 4, 6, 8 in those cells. That means the remaining cells must be 5, 7, or 9. And this can't be 9 because of the 9 in the box. This is 5, 7, or 9. This is 5, 7, or 9. Okay. Okay, so all the dominoes, there are going to be 40 dominoes because there are 81 spaces. There are 81 cells in a 9 by 9 grid, obviously, because it's 9 by 9. And we subtract out 1 for the digit that's in the red cage. And that's the only given digit. So, because of that, we know there are 80 spaces that we have to fill with dominoes, and each cell will be a part of a single domino. So that means there are 40 cells because each domino is obviously 2 cells long. Okay. We have 40 dominoes. First of all, you can't have 17 ever because as a domino, because 17 would imply that you have 17 dominoes, each adding up to 17, and you can only have 9 of them at most. Same with 16. 16 would imply 16 dominoes, each adding up to 16, and that doesn't work because you can have 9 at most, right? 7 and 9. 15 actually could work if you had 6, 9, and 7, 8 as pairs. So that gives you potentially 18 dominoes there. So 15 and under as dominoes could work. Also, you have to remember the total of all 40 dominoes must add up to what? The sum of all 40 dominoes must add up to 45, which is each row summed together, times 9. So 45 times 9 that's 45 45 times 9 is 45 in the sum plus 360. That's 405. And so 405 minus 9 is 396. So we need to add up to 396. I think that's correct, right? 45 times 8 is 40. 320, 360. 360 plus 45 is 405. Yeah. 405 minus 9 is 396. So we need to add up, the dominoes need to add up to 396. Well, what are possible dominoes sums? Again, we have 3, you could have 4, all the way up to 15. 5, 6, 7, 8, 9. And then we have double digits. 10. We have 11, 12, 13, 14, and 15. Well, 3, if you have 3, that adds up to 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. So that would be an 8 on the outside, 81. This would be 64. 10 times 10. So, okay, yeah. Because you have that amount of dominoes, it has to be essentially squared. So we have, again, 9, 16, 25, 36, 49, 64, 81, 100, obviously, 121, 144, 169, and 14 squared is 16 times 140. That's no, that's not right. 16 plus 40 plus another 140. It's 196. So we have 196, and then 15 squared would be 225. Okay. And we need 40 dominoes worth. Okay. What are possible combinations? 40 dominoes worth. How many is each of these? You have 9, 8, 7, 6. That's 35. 35 plus... Okay. We also know 9 has to be part of a 10, 11, 12, 13, 14, or 15 domino. 9 could be part of all the 10 dominoes. That is potentially possible. So we're guaranteed at least one of these, right? Um, We have 40 dominoes. Hmm. 10 obviously doesn't work by itself. If you have 10, then you say you had 9, 8, 7, 6. So that's the maximum value for just 10 as the largest one. You get 100 plus 81 plus 64 plus 49 plus 36. And we need to add up to 396. Oh, maybe that... Okay, let's give a calculator. So 100 plus 81 plus 64 plus 49 plus 36 is 330. So 10 can't be the largest sum. What about 11? You have 121 plus 81 plus 64 plus 49 plus potentially 25, right? Because we need 29 other dominoes. That's 340. Can you have 11 and 10 is kind of a question, right? 121 plus 100. That means 19 spread amongst the others, and it has to be exactly 19. So 5, 6, and 8. 3, 8, and 9. No, it'd have to be 3, 7, and 9. So plus... Okay, so 121 plus 100 plus 81 plus 49 plus 9 is too small. You can't have 8 and 2, though. So 11 cannot be the largest domino size either. And the thing is, like, every time you increase every time you have the largest domino size, that is more valuable than having smaller domino sizes, right? So we're looking for the maximum value for these, right? 12 is 144. You could have 11 and 10. 12, 11, 10. That's 31 left. 12, 11, and 10 each have what? That's what, 37 dominoes. No, 33 dominoes. So we have 7 left. Well, the only possibility would be 9 and 16, or a 7 by itself. So that won't work. But we potentially could have 12 and 11 plus 9. 356. Oh, whoops, 81, not 91. 121 plus 81. 346. That gives us, so 20, 32. So we have 8 dominoes left. Obviously 64 would not work by itself. It's too big. 3 and 5. It would have to be 3 and 5. That doesn't work. It's 380. Right, so we have to figure out what possible combinations would work. So, but 12 looks like it's starting to be where you can start playing with things. 11, it was just too small. The number of dominoes you could have, right? So we need to add up to 396. 12 is when you can start working with it. So 12 as the largest domino could work. What else do we have anything else restricted? Don't think so. Okay. So what other restrictions do we have potentially? Can we get 15? Possibly. Probably, actually. It gives us the widest range, right? So of things that we can potentially... It gives us 225 just by itself. So then we have... The other ones must add... The other number of dominoes must be 25. 3 plus 4 plus 5 plus 6 plus 7 is 25. So 9 plus 16 plus 25 plus 36 plus 49 plus 225 is 360. Right? So then we just need to change things so that it basically increases slightly. So yeah, it could be... So the largest domino could be from 12 to 15. We're not sure, right? All the so 8 of the 9s must be part of dominoes. All of the 8s, all of the 7s, all of the 6s. Yeah, so it obviously couldn't be 3, 4, 5, 6, 7 because then the 8s would be part of 6 of... Well, actually, so it'd be 6 and 9 would be part of every 15 cage. Because 9 would... Well, not necessarily. But you could have up to 15. Well, you have to have 15 if you have 15, right? That's 225. You could have up to 869 cages. You would have to have at least 7. So you could have 7 or 8 6-9 cages. Or I guess it's 6, 7, or 8 6-9 cages. You could have 7, 8, or 9 7, 8 cages, right? But the 8 has to be part either the 8 or the 9 has to be part of a couple other cages. So that's why you couldn't have 3, 4, 5, 6, 7 anyways. Um hmm. So we start with 12 as the maximum and then 13, 14, 15. So we have to look at all those possibilities for those specifically as the maximum domino size. Uh So 396. That's the magical number. That's a magical total sum we need to add up to. And it has to be with these perfect squares. Sums. Okay. What are the sums up to up to 12 squared? 9 plus 16 plus 25 plus 36 plus 49 plus 64 plus 81 plus 100. I guess I could have, well, no, I couldn't have necessarily. Plus 144. So 645 for all the sums up to 12. So we have to lose 249. That's interesting. I see one way of that on immediately, right? Can get rid of, and the number of dominoes has to stay the same. I can see already though to get rid of 249 it shouldn't be that hard. You can just get rid of 49, you can get rid of 100, and you can get rid of 36 and 64. And so does that count to the same number, to the exact number of dominoes we need? That would be 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. We subtract out 10 dominoes, 7 dominoes, 6 dominoes, and 8 dominoes. No, it's 44. Close, though. Hmm. Okay. Again, we have to get to 396, which is 450. 45 times 10, it would be 450. So subtract out a 45 from that, you get 405. 405 minus 9 is 396. So that's the magical number we need to get to sum up from the squares, because you have each domino sums up to a value, and that sum is the number of dominoes with that value. So that's why it's squared in value for the sum. The number of dominoes, which is each its own square. So the square root of the sums must equal 40. Okay. So the sum of the squares of the number of each dominoes. So the value of each domino is the number of dominoes with that value. So each value we choose must be squared and adds to the total sum, essentially. Hmm. 196 and 169. So again, we have 9 plus 16, 25 plus 36 plus 49 plus 64 plus 81 plus 100 plus 121 plus 144. 645 minus 396, which is target, so we need to lose 249. We lost too many dominoes there. Okay. Because we subtract... Okay, so 3 through 12 is 75. We need to lose 35 dominoes. And then the sum of those 35 dominoes must be 249. Maybe there's some mathematical equation you could come up with to figure that out. I don't know. The only thing I have is trial and error. How many dominoes do you have from all the way to 15? You have 117. Okay, we're trying with 12. We need to get rid of 249 the sum of equal to 249 of the squares. And we need to get rid of 35 for the actual sums of the dominoes. What are the possibilities here? 249. Can we get rid of the 11? 128. Actually, let's do it the other way. I mean, let's get rid of 35 sums, essentially, right? You could get rid of 98765. So 81 plus 64 plus 49 plus 36 plus 25. That's too large. Because, not by much, though. 255. So it's 249. Or we could get rid of what? 3 plus 4 plus 5 plus 6 plus 7 plus 10. That's 35. Right? So then we'd have 8, 9, 11, and 12. Each adds up to 40 dominoes. 40 so that would be 8 plus 9 plus 11 plus 12. It's 410. So it's slightly too big. Okay. So so 3, 4, 5. We got rid of 3 through 7. So we have 8, 9, 11, 12. We could do, we need, If we decrease the 11, that doesn't work, right? So with 12 as the largest, you could have 8, 9, 11, 12. We have to get rid of 35. So we got rid of the smallest ones and then 10, and that gives us what, 410, which is slightly too big. So we need to decrease some of them, 8, 9, or 11. So you could have 3, 5, 9, 11, 12, right? 9 plus 25 plus 81 plus 121 plus 144, 380, which is too small. Hmm. The problem is we need to decrease like 2 of them. Okay, so 11 could go down to 10. 11 could go down to 10. 8 could go down to 6. So that's a drop in 3 dominoes. So if we drop 11 down to 10 and 8 down to 6, we could add the 3 to get the dominoes back. So that would be 3 plus 6 plus 9 plus 10 plus 12. Yep. That adds up to 40 dominoes. 3, so it's 9 plus 36 plus 6 plus 81 plus 100 plus 144 is too small. So that was too much of a decrease. So for 4 sets for 12, I don't think it works. Well, it doesn't work. You have to have, it has to be 8, 9, 11, and 12 exactly to add up to 40 dominoes. And that sum is too big. And you can't decrease things with 12 as the highest, right? Because if you try to decrease the 11, this 8 goes up to 9, and the 9 would go up to 10, but we already have the 8 and the 9 uniquely there. So that doesn't work for 4. For 5, okay, so let's go for 5. 5 sets. What is the maximum for 5 sets? Actually, I forgot. Okay, 12, 11. You could have 12, 11 for 4 sets. You can't have 3 sets, right? 12, 11, and 10 only add up to 33. So that's 33 sets. You have to have a 4th. So if you have 12, 11, 10, obviously it's too much. Still, because you jump the 9 to the 10, and then you drop the 8 to the 7. And that's always going to increase the value because you have a double. You're increasing 9 from being 9 squared to 10 squared. That's a gain of 81 to 100, which is 19. And you're dropping from 8 squared, which is 64, to 7 squared, which is 49. So that's 15, right? So that's not going to work. I'll show it here. 144 plus 121 plus 100 plus 49 is 414, right? Which is 4 more than the 410, right? Because that makes sense. We gained 19 and we lost 15 from 64 to 49. Oh, that's actually interesting. Huh. Okay, so for 5 sets, adding up to 12. You can't have 12, 11, 10, 9. You could have 12, 11, 10, 4, and 3. So 144 plus 121 plus 100 plus 16 plus 9 is 390. That's too small. So 5 sets, I think, does not work. So I think 12 we can rule out then, right? 6 is just going to be even worse, right? Because, so we tried 12, 11, 10, 3, and 4. You're always going to be decreasing one of the larger ones to increase one of the smaller ones. And so that decrease, that jump from 100 to like 81 will be decreasing too much compared to the leap from 16 to 25, or say, for 5 cells. And that just gets worse for the six sets. Sorry, not 5 sets. It's not 5 cells, it's 5 sets. So that doesn't work then. So 12 cannot be the largest, right? We tried the minimum, which was 4. That gave you too much, which is 414. And we tried to set it up so that it would work in some way, but it just doesn't, right? It just, the sums don't add up with the number of dominoes we have. So from that, if we tried 5, it will necessarily decrease things, right? Because instead of having the 4 largest sets, which will give us the greatest squaring of these sets, you have to split it up into 2 smaller ones, which is necessarily going to be smaller, right? 7 divided into 3 and 4 is going to be necessarily smaller. 10 divided into 4 and 6 sets is necessarily going to be smaller, right? 10, if you have 10 sets of 10, that's 100. If you have 6 sets of 6 and 4 sets of 4, that's 16 plus 36, which is 52, right? And so that drop off from 4 sets to 5 sets is already too small. So we've shown then that 12 cannot be the largest sum. It must be at least 13. So can we have 4 sets adding up to 396 from 13 is kind of the question. Or maybe 5 sets could work. Let's try. 13 plus 12 plus 11. That's the largest one. 13 plus 12 plus 11. That gives us 4 for the last one. And that gives us a lot of leeway. That's 169 plus 144 plus 121 plus 16. Yeah, it's 450, which is much higher than 396. So we can decrease some of the larger sets. So 13 still has to remain because that's the highest, right? We tried it with 12. 12 doesn't work. So if we try with 13... Actually, that's a good question. Can we have sets that are 6 or more add up to 396 ever, right? Or 7 and more. And that includes 15, right? So let's start with 7, because that's the largest one we have to have. So 7 sets. We have 3 plus 4 plus 5 plus 6 plus 7 plus 8. And then plus 9. Okay, so you cannot have 7 sets. Because the minimum would be, again, 3, 4, 5, 6, 7, 8, 9. And that's already 42 sets. 42 dominoes accounted for if we try to have 7 sets. So what happens if we try to have 6 sets? Okay, so obviously 6 is less than that. The question is, can we get a sum equal to that? So 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Not plus 9. So it's plus 8. We have 7 degrees of freedom. We could jump the 8 all the way up to 15. And that would be the best increase, I think. So 3 plus 4 plus 5 plus 6 plus 7 plus 15. I think that would be the largest one, right? It'll be better than 14 and 9. Because again, you have the difference between 8 and 9, 64 to 81, which is 17. And the difference between 14 and 15, which is 225, minus 196, which would be 29. Right, so you would gain 20, you would lose 29 if you went from 15 to 14, and gain 17 by going up from 8 to 9, and that's too much. So you basically, so this is the largest 6 set sum you could have. Is 3, 5, 4, 5, 6, 7, 15. So 9 plus 16 plus 25 plus 36 plus 49 plus 225. It's 360, so it's too small. You can't have 6 sets. Now it's either 5 or 4. Okay. 4 definitely can fit. Can get to 400 and... Oh, sorry, 396. 5. Can 5 get to 396? Probably. Uh, Minimum would be... So with the maximum values, you can't have 15, 14, 13. You have to have 3 plus 4 plus 5 at least. That's 12. That means the other two is sets must add up to 28. So that's 15 and 13. So 3, 4, and 5 plus 13 and 15 adds up to 40 dominoes. And then we add those up together. So 9 plus 16 plus 25 plus 169 plus 225 is 444. So 5 can do it. And it's a matter, can we actually add up? So we have 5 sets or 4 sets. We know that guaranteed. We tried 6 sets. It doesn't work. We tried the maximal amount of maximizing the sum of the squares, and it just doesn't work. It's not large enough. 5 sets works. 4 sets definitely works. So the question is, can we get 5 sets adding up to 396 or 4 sets adding up to 396? Let's try 4 sets. Actually, before we do that, I'm going to pause and go to the bathroom. I'll be right back. And I'm back. Let's continue. Okay. So, the 5 sets or 4 sets? Where do we want to start? 5 sets? 5 sets is pretty limited, right? We have 444 as the maximum. And we need to get to 396, so that might be better. So 3, 4, 5, we try 3, 4, 5, 13, 15. What happens if it's 3, 4, 6, 12, 15? Right? So 3, 4, 6, 9 plus 16 plus... Okay. So 3... Okay, let's... Yeah, 3, 4, 6, 12, 15. Well, that won't be enough, actually. Right, because we're increasing the 5 by the square sum from 25 to 36. That's 11. And we're decreasing from 169 to 144. Well, yeah, so that won't be enough. 169 minus 144 is 25. Oh yeah, let's look at the differences here. So this would be a gain of 7 here. This would be a gain of 9. This is a gain of 11 between each set. So the gain of 13, it should be 15. Yep. 17, a gain of 19. This would be a gain of 21, right? 23, 25, 27, 29, and then 31. There's no 31. So those are the differences between the sum of the squares. We have what, 444? Okay. So 444 minus 396. The difference is 48. Okay. Again, we have 3, 4, 5. Um, 3, 4, 5. So we have to decrease by 48. Okay. 5, obviously, if it increases to 6, that's a gain of 11. And then you could correspondingly go from 13 to 12. Or 15, actually. Probably going to 15 might be... From 15 to 14 would be better, right? So 3, 4, 6. So that would be gain of 11, and you lose 29. So that would be a net loss of 18. Hmm. Or we could drop 15 to 12. If we drop 15 to 12, we could increase another digit, like 3, up to 6 or something. Okay. Let's try that. So instead of dropping 13, let's try dropping 15. See if that works. If we drop 15 to 12, that means we have 4, 5, 6. 4 plus 5 plus 6 plus 12 plus 13, which is 40 dominoes. That would mean 144 plus 169 plus 16 plus 25 plus 36. Almost. It's too much. So that means for 5 sets, you cannot have 13 be the highest digit set. It has to be at least 14. Because we tried to drop 13 to 12. Oh, wait, but... Or we could increase 5 up to 8. That might work too. Because we increased it too much. Or we can increase 4 up to 7. Okay, let's try that. So 3, 5, 7, 4 up to 7. So 7, 12, and 13, right? 3 plus 5 plus 7 plus 12 plus 13. That adds up to 40. 9 plus 25 plus 49 plus 144 plus 169 is 396. So we do have a set that adds up to 396 for 5 digits. And that's 13 at maximum. So 3, 5, 7, 12, 13. Can there be any other set of 5 that adds up to the same? I don't know. I don't think so, actually. That might be a good question. So we have 3. So we're going to mark it with the... Yeah, let's mark it here. We have 3, 5, 7, 12, 13 as a possibility. Can you actually have it be some other combination of 5? And I think the answer to that probably is no. Right? Because you're changing certain ones to other ones. Right? So you'd have to increase up to like 14. You would have to decrease these and then increase these a certain amount. And I just don't think you can get back to the same sum with that. Now, 4 might work. But the question is, yeah, I mean, I don't think 5 sets would work in that way. Yeah, 9 plus 25 plus 49 plus 144 plus 169. Also, for this domino, whatever, this equal sum line, essentially. I guess it's the equal sum line. It's just separated by domino borders. What we know is these two cannot be in the same domino, so they're guaranteed to be different. I think this has to be this one domino here. Because if it's not, then these would have to be the same digit guaranteed. So these two must always add up to this. So it cannot be... Okay, so these two then, I think, have to be 1 and 2. Right? So I think we're guaranteed that we have to have a 3 here. Which I think means that the 4 set is never going to work. Because I'm guessing that the 4 sets adding up to 396 will never have a 3 in it. It's just too big of a difference, right? Because you can't have 3, 6 here adding up to 9 because 9's already in that row. And you can't have 4, 8 here because that would be 12. And this is guaranteed 1, 2, 3, 6, or 4, 8 because of the row 9. So because of that, well, first of all, we know this is a domino. I think it then has to be 1, 2, right? If this is not the same domino, say it went here and here, the problem is this would have to be the same set digit as that, and we'd have a repeat in the box. So this has to be a domino here. It cannot be 3, 6, because that would add up to 9, and we have a 9 in that row already. So it must be 1, 2, and 3 here then. So this must be 1, 2. This has to be a 3. So 1, 2 cannot be in the rest of the row. This must be a 3 then. And that does show up other stuff. Okay, that's interesting. So this is kind of similar. So we know a domino has to have a 3. So we're guaranteed that then. So how can the other 4 dominoes add up to 396? I don't think it can, right? Can 3, a set of 3 sets add up to 396? Maybe. But without with the 3, probably not, would be my guess. But so I think it is probably 5, 7, 12, 13 are the sums. But we don't know. What other ones with 3s could we have? So, could you decrease 4 and increase 7 and then decrease 12 and increase 13? Maybe? Let's try that. So 9 plus 16 plus 64, because we increased 7, we plus 121 plus 196. That's 406. Yeah, I think it's just there's just two. I don't think there's a way to even these out, right? For 4 sets. I think this is the set essentially that you can have. 13 jumping to 15 would mean a decrease, but that's already you're gaining so much. You're not gonna lose enough dropping the 12, right? Maybe if you drop the 12 and you increase the 7 and you also drop the 5? So that means 12 to 11, 5 to 4, and 7 to 9. So we have 3 plus 4 plus 9 plus 11 plus 13. Right, so increasing the 13 won't help, because that will increase things way too much for each one that you decrease, right? So you can't increase the 12. Maybe you can increase the 12 to 4. Well, that's the same as dropping the 13 to 10. Okay, let's add that up. I'm pretty sure that's not going to work. So 9 plus 16 plus 81 plus 121 plus 169. Oh, no, that works too. Okay, so no, we do have that. Okay, there are other 5 sets that can work. Huh. Okay, that's problematic. Okay, so I was wrong. We have 3, 5, 7, 12, 13 as a possibility. Oh man, this is gonna be crazy. So we have 3, 5. Okay, so what are the possibilities? We know we have a 3 set. 3, 5. Maybe we can eliminate all the 4 sets because we try out all the 4 sets with 3. 3, 5, 7, 12, 13. What else? We have 3, 4, 9, 11, 13. Oh. Okay. So we 3, 4, 9, 11. 11 and 14? Is that right? 3, 4, 9, 11, 14. Hmm. Okay, there might be other sets of 5 that work. Can we eliminate at least the sets of 4? Uh, um, hmm. Oh, interesting. Hmm. This is actually helpful here, right? Because these dominoes have to be this. One of these have to be a domino, which adds up to the other domino. It cannot be 1, 2, and 1, because then these digits would be the same. It can't be obviously 1 and 1, and again, the dominoes will break it up into 2. So this must be 2 and 2. So that's probably helpful, too. Maybe we should look at this. We should focus on this instead. These are the digits again, 1, 2, 3, 4, 6, and 8. Obviously, this can't be 1, 2, because then that would be 1, 2 here. You cannot have 4 and 8 be here either. So you're guaranteed a 9. This has to be 9. Right? Because if you, again, you can't have 3 here because that doesn't equal, you can't have another 3 in the box, right? You've already used up the 1 and 2. If you try to have 4 and 8 here, the problem is every other combination of 12 requires a digit that's not from 1, 2, 3, 4, 6, and 8, right? 3 and 9 or 5 and 7. So that can't be 4 and 8. Therefore, this must be 3 and 6. That must add up with these two. So it has to be 1 and 8 here. So this must be a 9. So you have to have 3 and 9 guaranteed. That means you either have 3 sets, which add up to 28, or 2 sets that add up to 28. And I don't think 2 sets adding up to 28 will work. Right? So you have 3 plus 9, that's 28. 12 minus 40, that's 28. 2 sets would be 13, has to be 13 and 15. So 169 plus 225 plus 81 plus 9. Yeah, it's way too big. So it has to be 5 sets. We can rule out 3, 5, 7, 12, 13 now. We have 3 and 9. 4, 11, and 14 work. So we're guaranteed a 9. So this is a domino, and this is a domino. We know we have 3 and 9. This is a 2-4 pair. The rest of that box must be 5, 7, and 9. This is a domino, obviously. How do these dominoes work, potentially? I don't know. So this must be a domino, this is a domino. Because we know the border has to cut across there. This must be a set. So this is a single digit. Where can the single digit be? We have 3, we have 9 guaranteed. We know 4, 11, and 14 work. So we know these are guaranteed. 4, let's mark it as blue. 4, 11, and 14 works to add up to 396. What else do we have? Can we ever have a 6 is kind of a question, right? If not, then this can't be a domino here. Oh, this can't be 9. That's interesting. Oh, what are the possible dominoes here? So we have 6 here. We have 2, 7, 2, 5, 4, 5. Oh, 4, 5 obviously works fine. This has to be part of a domino here or a domino here. I'm thinking it probably has. Well, I thought we would have only one set of 5, but it's actually not true. What other dominoes do we have? We have. Can you have 6 is kind of the question, right? So you have 3, 6, and 9. Say we have 3, 6, and 9 guaranteed. That's 18. Minus 40. That means the other 2 sets must add up to 22. So 3, 6, 9, and then we need 22. So that would be 10 and 12, or 8 and 14. Okay. So 3 plus 6 plus 9 plus 10 plus 12 is 40. Let's add up the sum. 9 plus 36 plus 81 plus 100 plus 144. It's too small. So what if we try the larger one, right? 3, 6, 8, 9, 14. Right? 3 plus 6 plus 8 plus 9 plus 14. Yep. So that would be 9 plus 3 plus 6, 36 plus 8, 64 plus 9, 81 plus 14, 196. 386, still too small. So you cannot have 6 as a set, as one of these sets here. So this has to be the domino. So we are guaranteed a domino here. We are guaranteed a domino. Well, not guaranteed, actually, to go that way. This one also must go this way, then. Okay. What if we tried... Okay, so these could be, again, obviously 9 works here. Fine. But can you have 2 and 5... or 4 and 7 be the other domino here? And I think the answer probably is no. Let's try it. Okay, so we guaranteed 3 as a set and 9 as a set. If we tried 7 as a set, that's 19. The other two sets must add up to 21, which is 40 minus 19. So that would have to be 10 and 11, if that's possible. So 3 plus 6, sorry, 3 plus 7. 3 plus 7 plus 9 plus 10 plus 11. I think that's too small, would be my guess. So 9 plus 49 plus 81 plus 100 plus 121. Yeah, 360 is too small. We need 396. So what if... So what are the other possibilities? You add up to 21, 15, and 6, I guess? 3 plus 6 plus 7 plus 9 plus 15. Wait, did we try this one before? I don't know if we tried this one. 9 plus 36 plus 49 plus 81 plus 225. It's too large, 400. It's actually kind of close, though. You can't have 3, 7, 7, obviously, because we have already 7 there. 3, 7, 8, 9, 13, right? Okay. That would be 9 plus 49 plus 64 plus 81 plus 169. It's too small. Okay, so it cannot be 7 here. What about 11? Maybe we could work with 11. So 3 plus 9 plus 11 is 23. That means the remaining two sets must add up to 17, right? 40 minus 23 is 17. You already have a 3. We have 9. We have 11 in this case. Yeah, I forgot 7 and 15. I was actually close. Good thing I checked that the other side, but anyways. What happens if we have 3... Okay, so we have 3, 9, and 11 guaranteed, right? We need others to add up to 17. So 4 and 13 is a possibility. 3 plus 4 plus 9 plus 11 plus 13. I don't think that's valid. Wait, how did I get 3, 4, 9, 11, 14? Huh. Okay, that's kind of problematic. I think I miscalculated there. Interesting. Well, let's try 9 plus 16 plus 81 plus 121 plus 169. Oh, it's 169, so it's 13. So that is... Okay, so this could be... Okay, so... This could be 11 there. It's 11, 13. So that... I don't know how I got 14. Anyways. Right. So 3, 4, 9, 11, 13. That was the one that we calculated originally. I just accidentally had 13 go up to 14. So this could be 11 here. Ugh. Okay. Oh, one of these is a 4-8 pair, right? So one of these is 4-8. One of these, at least one of these is 4-8. The other one's 1-2. Therefore, this cannot be 4 and 8 here. So this must be a 3-6 pair here. That 3-6 pair eliminates 3 and 6 in the rest of the row. So it has to be 4-8 here. That must mean... Okay, can we have these sets, essentially? So these being, essentially, the other sets. I think the answer probably is no. Anyways, let's try it. 3 and 5 would be 8. So we have 3 plus 8 plus 9 is 20. So that means the other two sets add up to 20. You could have 15 and 5. So 3 plus 5 plus 8 plus 9 plus 15. That adds up to 40. So that's 3 plus 5, 9 plus 25 plus 64 plus 81 plus 225 is 4. Too large, but not by much. So if we increase the 6 and decrease the 14, I think it won't be enough. It'll be close, actually. So 3 plus 6 plus 8 plus 9 plus 14. That would mean 9 plus 36 plus 64 plus 81 plus... Actually, it might be too much. It's too much. Okay. So that doesn't work. So 8 does not work. What happens if we... So that's 3 and 5. 3 and 7 is 10. What happens if we have 3, 9, and 10? That's 22, so the other two sets must add up to 18. Can't have 3 and 15. 4 and 14 is possible. So we have 3 plus 4 plus 9 plus 10 plus 14. That means 9 plus 16 plus 81 plus 100 plus 196 is 42, slightly too big, and I don't think we could decrease it. So that would be 3 plus 5 plus 9 plus 10 plus 13. I think that's too much. So that'd be 9 plus 25 plus 81 plus 100 plus 13, 169. Yeah, it decreased it too much. 384. So 10 doesn't work. What about, we already have 11. So it could be 6 and 5. And then 6 and 7 we showed works 13 if you have 4 and 11. Huh. So this could be a domino here. Or this could just maintain the domino here, right? So 3, 4, 9, it seems like 3, 4, 9, 11, 13 is probably the one that works. Can 12 ever be a domino? So can this ever be a domino here? I think the answer to that is probably no. Right? So 3, 9, and 12 would be the sets, at least guaranteed. The other two sets must add up to 40 minus 24, which is 16. 16, you could have, again, 12 we already have. So it would be 5 and 11. That seems too small. 3 plus 5 plus 9 plus 11 plus 12. Which would be 9. I think we already tried that. Well, we were close. 9 plus 25 plus 81 plus 121 plus 144 is 380. It's too small. Yeah. And then everything else decreases because you're decreasing the topmost value. Yeah, so 12 does not work as a domino. Therefore, it must be either this way or it must be this way. Okay, so if it cuts this way, that's not going to work. Because then that would force these to be the same digit. So it must go this way. So we know this is the domino here. You could have domino here, domino here. So this has to be either there or this way. It could be 1, 2, 3. That's possible. It could be 9. Or it could be this extra one that we have, 4, right? Oh, it can't be 4. Well, it could be 3, 1, 4. Oh, no, it can't be 4. So this must have to add up to 3 or 9 here. So this is 3 or 9. Probably. Doesn't that mean this is a domino? 4 cannot be here because of the 4 pair. This is a domino. That's interesting. obviously it adds up to... It adds up to 9 here. Possibly 4 and 5 works. Can 8 add up with any of these? 13. 8 and 5 works. 8 and 9 would not work as a domino. Can we get 5 as a dom? Okay, so we tried 6, we tried 7. I think we tried 8 too as potential other sets. So we've ruled out all of those sets as working to add up to the completed one, right? Yeah, you can't see this necessarily, but I've been using this history to try to keep track of that. 3, 4. Yeah, I don't have that though. I don't have the full history. Why don't we try that? Let's try all the small numbers here, right? Because if you have a bigger number, you're guaranteed to have a smaller number here, right? If you have a 10, that means, so we have 3, 9. You can't have 13 and 15 for 4 sets. And that would have to be the case to add up to 40. If you try to have a 10, 3, 9, and 10 already adds up to 22. So you'd have to have 2 sets adding up to 18. And so that's not possible without a lesser set than 9, right? So let's try all these combinations without... We know 3, 4, 9, 11, 13 work. What about other sets? So say we had a guarantee 3, 5, and 9. That's 17. The other 2 sets must add up to 23. So 23 could be 15 and 8, plus 3, 5, and 9. So it'd be 9. Let's look at our history. 3, 5, 9, 3, 5, 8, 9, 15. So 9 plus 25 plus 64 plus 81 plus 225. 4 4 too large. So what if that's with 3 and 5. What if we decrease 8 to 7? No, okay, we can't. So 8 would have to jump to 10, and 15 would have to drop to 13. And that's going to be slightly different than 3, 4, 9, 11, 13. So that would have to test 3. So that would test, again, we're assuming 3, 5, and 9. 3, 5, and 9. You could not have the 8 and 15. So you'd have to increase to at least 10 and 13, right? So that would be 9 plus 25 plus 81 plus 100 plus 169. Yeah, it drops too much. 384. We're getting that 384 number quite a bit. Anyways. So that's assuming 5. I think we already assumed 6, but we could try it as an exercise again, right? Say we had... so 5 does not work. What about 6? That's 20. The sums must add up. The sets must add up to 22. So 15 and 7. So we have 3 plus 6 plus 7 plus 9 plus 15. That's 40. So that would be 9 plus 36 plus 7, 49 plus 81 plus 225. Again, 400's too big. And if we increase the 7 and decrease the 15, it's going to be too much of a drop. So 3 plus 6 plus 8 plus 9 plus 14 would be the sum of the squares is 9 plus 36 plus 64 plus 81 plus 196. It's 386. Yes, it dropped too much. What else? Uh, so 3 and 6 doesn't work. Sorry. Yeah, assuming 3, we have 3, we have guaranteed 3 and 9. We don't, if we assume 6, that doesn't work. 3 and 7, I think we already tried. So it'd be 3, 7, and 3, 8, but we'll try it again. 3, 7, and 9. That means 19, which means the two sets add up to 21. We tried 3, 6, 7, 9, 15 already, and that adds up to too much. If we go to 3, 7, 8, 9, 13, that's going to drop it too much, right? 3 plus 7 plus 8 plus 9 plus 13 is the sum of the squares is 9 plus 49 plus 64 plus 81 plus 169. It drops it too much, 372. So 7 doesn't work. What about 8? And I think we tried this last. So 3 and 8 and 9 is 20. So the two sets must add up to 20. 40 minus 20 is 20. That means we tried 5 and 15. 3 plus 5 plus 8 plus 9 plus 15 is 40. So 9 plus 25 plus 64 plus 81 plus 225 is 4. 4 is too large. If we increase the 5 to the 6 and decrease the 15 to the 14, I'm sure that it's going to be too big of a drop. But let's try it. 9 plus 36 plus 64 plus 81 plus 196. Yes, it drops to 386, which is too much. Oh, and we already tried that, right? So, we've shown that any other set does not work from 5 through 8. With 3 and 9 guaranteed, you have to have 3, 4, 9, 11, 13. So that's just what we have. Okay. So we can clear out all of this information so we can start figuring out the Sudoku. So we have, okay, it's 3, 4, 9, 11, and 13 that add up to 396, and that's guaranteed because we know we have to have a 3, we have to have a 9. Just to double check, then we have 9 plus 16 plus 81 plus 121 plus 169. Does that 396, which is the sum that we're going for. Okay, so this is 1 and 8, 3 and 6. This must be part of this or this. Okay, this could be another 9. We don't know. This could be 9. So can you ever have a 9 here? Yes, it could add up to 4, 9 to add up to 13. So this is... It cannot add up to 4 for this domino. It must add up to 3 or 9. And 3 or 9 cannot be the single digit here. So this must be a domino here. And this is 3 or 9. We're not sure which. If it's not... Okay, so if it's 3, this is 1, 2. If it's 9, it cannot be 1, 8. It cannot be 4, 5. And it cannot be 3, 6. So it's 2 and 7 if that's the case. So either way, this has to be a 2, right? It cannot be 1, 8, again, because of the 4, 8 pair in the box. Can't be 4, 5 because of the 4, 4, 8 pair in the box. Can't be 3, 6 because of the 3 in the row. So this is guaranteed to be a 2. That's interesting. 3 must be one of these 3, right? Okay, so we have a 3 3s, 4 4s. So every one, 3 3s and 4 4s. Every one has to be, we have 3 2s that the one is in a domino with, 4 threes that the 1 is on domino with, and then you have to have 2 nines, right? And this is already one of the nines. Um, okay, yeah. So domino, what can each digit be a part of, or has to be a part of, essentially? You have 3 threes, so you have 1 and 2. So 1 is part of. Okay, let's show that again. 1 is part of with 3 twos. So you have 3 twos. Actually, let's move these over. Or we could have the 1 essentially be here. So this is 1, 2, 3. Let's do 9, 8, and 7 potentially. So 1 has to be part of 3 twos. So 3 of those, 4 of those, and 2 of the 9s. Because it can't be 11 and it can't be 13. 2 will be part of 3 twos. It could be 6 nines, except that this is already a 3 6 here. Not sure. 3 is part of 4 fours. Okay, so 2 twos, and we don't know how many of these each. Okay, so 9. We have 8 nines we have to be part of. It could be all 8 13s. There's also 11s it could be part of. It could be it could be all 8 11s for the 9, right? 2 and 9. Okay. So we have all the ones we know are part of stuff. What about twos? We have 3 of them accounted for. We need. So 2 and 3 cannot ever be part of a 13 domino. So they have to be part of a 9 or 11 domino. So we have 6 spread amongst the 9 and the 11 here. And then another 5 spread for the 3s across 9 and 11. Oh, so 9 cannot be the full set of just 8 11s, right? Because we only have 6 twos available for that. So it's at most 6 11s. It has to be at least 2 13s. Interesting. Okay. So we have accounted for the 1s and 2s. We have 3s. We have the 4s. And we have 13 9s and 11s. So that means 7 more 9s and 11. Obviously 13 13s. Okay, so what do we have? We know this is, oops. We're looking at edges. This is a boundary, obviously. This is a boundary. Nine cannot be with 3. But 9 could go this way as a domino. Yeah. Unfortunately, that doesn't tell us too much. We know we have two eights that are already claimed by the one being with the to add up to 9. But that doesn't tell us very much. So we know we have a guaranteed 2 here. We don't know if we have 6 11s for the 2 with the 2. Or if the 2 goes to 2 and 7 with the 9. Hmm. The rest of box 7 has to be 4 through 9. And obviously 9 cannot be either of these. Hmm. Okay. What else do we have? We have to place a correct digit somewhere. I don't know if we have enough information to do that, though. Hmm. One of these is 9. If this is 9, it cannot be part of 3 with a domino. If this is 9, it has to be a domino here. The 9 must be with the 4. Because it cannot be with 2 otherwise. The 9 can only be with 2s and 4s, essentially. Um, 9s can be with 2s and 4s at dominoes. So, if that's the case, this is 9 2 7 as a domino. That would force this to be 9. So that would cannot be with 3. These are not domino. This is a separate domino here to force this this equal sum line to work. So this would be 9 and 4 here, which would force this to be 8. It cannot be 7. It would have to be 8 and 5 here. And that does work. Hmm. What if this is 1 and 2 and that's 3? We do already have a 1-8 pair and a 3-6 pair here for the 9s. We need another 1-8 pair somewhere as a domino. What are the rest of the digits in box 9? We have 1, 2, 4, 5, 7, and 8. Okay, 2 cannot be any of these. The rest of column 9 has to be 1, 2, 4, 5, 7, 8, and it could include a 9. Except that if this were 9, this is guaranteed to be its domino, because it can't be 6, and this has to be there. So this must go this way. So this cannot be 9, because it would be with 5 or 7, which is not the sum that it can add up to. 1 has to be with 2, 3, or 8. So this can't be 1. 2 could be with 9. 4 could be with 5. 4 could be with 7. 5 could be... Cannot be with 7 or 9, so this can't be 5 here. 7 doesn't work either. 7 cannot be with 5 or 9. Oh, interesting. We have even and odd digits, too. Splits. So all... Right. Except for 1 and 3. All the odd digits have to be with an even digit. Huh. Interesting. This is an odd digit. Well, it could be with the even digit here. So 5 and 6 and 7 and 6 both work. This can't be 3. Except that this could be a domino. Yeah. If this is 5, it could be 4 here. 5 and 8 work too. 7 does not work with anything else because this can't be 2. Interesting. Okay. So we know... This must be a domino with this one or this one. Aside from 1, 3, every domino has to have an even and an odd digit. But we don't have anything else there. Oh, right. That's why 4 and 8 cannot be dominoes together. That's why 2 and 4 can't be dominoes together. This is 2. The rest is a 6. Oh, this can't be a domino with this. Because these are all odd digits. 3 can only be a domino with 1 as an odd digit. So this has to be a domino here. Guaranteed. 5 can be with 8. 7 cannot be with 8. Can this ever be 7 then? 7 can be with 4. But one of these is 9, and that has to be with 4 too. So one of these is 8. 8 has to be with 5 out of 5, 7, or 9. So one of these is 8. Ah, very clever. This has to be 8 and 5 or 4 and 9. That makes a 5, 9, 5, 9 pair in row 9. That means this can't be 5 or 9. This has to be a 7. So since this is 7, aha, we get more information there. That was rough, but that was very clever, too, at the same time. This is 5 or 9 also. Okay. So again, a domino is at most 2 digits. So every segment of an equal sum line will add up to at least 2 digits. And it could add up to 1 digit, but that's it. It can never add up to 3 digits. Okay, so is this ever 1, 2, and 3? Sorry. It can always be 1, 2, and 3 here as separate segments. Can it ever have a separate segment here? No. So if it did have a separate segment, it could not be here. Sorry, a single cell separated. If we had a single cell separated as a segment, it would have to be one of these two and one of these two. But, so say it was here. This is a segment. This would have to be a segment, and then this would be separated. Because if we actually could have a single segment there. That could work. Huh. Okay. Obviously, it can't be 1 and 2. And then this is 3, and then this is... Yeah, it just doesn't work. Okay, this, okay, one thing we know, okay, yeah, this can never be 1, 2. Because the single segment, even if this is, so if this were essentially segment, 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 the problem is 1, 2, 1, 2, and 1, 2 doesn't work because they would have duplicates in the row and column and box. So if it's divided this way, so it can either be divided here and here, or it could be split this, this, and this. Right? The single digit cannot be here and here. So we're okay, so one thing we're guaranteed is that this has to be a segment, no matter what. If we try to cut it this way, single, double, you can't have a single anywhere here because they would be the same digit in the same row. So this is always cut this way, and we don't know how this segment is broken into. Therefore, it cannot be 1, 2, because it would be 3 and then another 1, 2, which is not possible. So this has to be a 3, 6 pair. Because this is a 3, 6 pair, we know this can't be 3 anymore. This has to be a 9. So this is 9. This has to be a 2, 7 pair. That means this cannot be 9. This is a 5. So this is 5. This has to be with 8 because the 9 has to be with 4. So this is 4 and 8. 9 has to be with 2 or 4 to add up to 11 or 13. So this must be a domino this way. And it's 2 or 4 here. Oops. We're not sure which. Okay, this is 3, 6. So either this is 9 or this is a domino that adds up to 9. We're not sure which. This cannot be 9 as a single domino. Therefore, these must be dominoes adding up to 9. So we know this is a boundary too. So we know this is a domino. This is a domino. And this must be a domino. Okay. Let's remove all of these. Okay. Remaining digits in column 5. We cannot have 3, 6, 8, or 9. So it's 1, 2, 4, 5, 7. Okay, this must add up to 9. Cannot be 4, 5, cannot be 3, 6. It could be 1, 8, or 2, 7. Cannot be 2, 7 because of the 2, 7 pair. That would eliminate all possibilities for that cell. Remaining digits in box 8. We have 1, 3, and 6. This can't be 3 here. So this is 1, 3, or 6. This can't be 1 anymore. So 1 has to be one of these two. This is a 1, 8 pair. Cannot be 1, 8. Cannot be 3, 6. So it's either 2, 7 or 4, 5. We're not sure which. This is a 7. That means the rest of the column cannot be 7. This can't be 1. 2, 4, 5, 7. Okay, so this could go either of these ways. This could be 1, 3 here. This could be 1, 3 here. This could be 6, 3. Okay, we have a 9 domino, a 9 domino, a 9 domino. So it's 5 9 dominoes already. And we have both 1, 8s. So the rest of the 1s must be counted for as 1, 2s or 1, 3s. Okay. None of these can be 9. The ones in besides box 2 and box 6 have to be one with 2 or one with 3. Okay. That means one of these is a 1. It could be with 1 and 2 or 1 and 3, but we're not sure. Okay, this can't be 2 or 4 because of the 2-4 pair in the row. If this were 1, I guess it could go up here. Okay, this can't be 5 or 7 because of the 5, 7, 9 triplet in the row. Okay, so what is the rest of row 4? Again, 1, 2, 3, 4, 6, 8, right? 1, 2, 3, 4, 6, 8, but 1 cannot be in the rest of box 5. If this were 1, it would have to be a domino with that. If this were 1, it could be a domino with either of these. It would not be a domino with this. This can't be 3 because of the 3 in the column. The rest of row 5 cannot contain 2 or 4. So we have 1, 3, 5, 6, 7, 9, 8, 9. 1, 3, 5, 6, 7, 8, 9. This can't be... Okay, this can't be 8 because of the 1, 8 pair in the column. This can't be 5, 1, or 8 because of the 1, 8 pair in the column and the 5 in the column. This can't be 4. Okay. This can't be 3 or 9 because of the 3 or 9 in the column. Rest of... Okay, this can't be 1 because of one of the ones has to be here. Okay, what are the remaining digits in column? Okay, well, there you go. In box 2. It's 2, 4, 5, 7, 9. But 4 cannot be here. Therefore, this must be 4 here. This is 2, 4, no 5, 7, or 9. So 4 has to be one of these two, which means this cannot be a 4. It's either 2 with 9 or 8 with 5. And we still don't know which one. We have 1, 2, 3, 4 dominoes guaranteed in box 9. Therefore, this cannot go this way. This has to go that way. So I'll mark that as blue. I'm not sure what this is, though. Could be another 3 or 6. Okay, this can't... Okay, what digits can this be? Can't be 1, 5, or 8. So 2, 3, 4, 6, 7, 9. The rest of the row can be 2, 3, 4, 5, 6, 7, 9. But 4 cannot be here. 3 and 9 cannot be here. Okay. Obviously 3, 6, 3, 6 works. 2 cannot be with either of these. 2 can't be with 3 because that adds up to 5. 2 can't be with 6 because it adds up to 8. Obviously 3 and 6 could be here. 4 doesn't work because 4 would have to be with 3. Again, because every even digit must be with an odd digit. Every even digit must be with an odd digit. And that would be 4 and 3, which adds up to 7. 7 and 6 works. 9 could have to be with 6, and that doesn't work. So this cannot be 9. Okay. Hmm. 4 is one of these digits. It's 2 and 8. The 1 could be with 3 here, and then 6 and 7 works. Okay, we have 2 13s. We have a 9 here, 9 here, 9 here. That's 3 9s here. This makes another 6. So we only have 3 9s available left. Hmm. The 1 could be with the 3, actually, in either of these spots. Hmm. Well, no, this could go this way. Hmm. Okay, so this has to be a domino here. So that's a domino. This has to be a domino, which means this has to be a domino here. That means we don't have a guarantee there. So this is a domino, this is a domino, this is a domino, this is a domino. Huh. Can you have a 2 or an 8 here? We know this adds up to 9. Oh, that's interesting. What happens if this is 2? That makes this a 4-5 pair. We cannot have 1 and 8 together. So if this is 2, that guarantees this is 4-5. We only have 1, 8, and 9 here. 8 and 9 add up to 17, which is not a set. And 1 and 8, we already have the 2 1 8 pairs that we need. So this can never be 2. This has to be 8. So this is 8, this is 5, this is 7, this is 9. Okay. That means this can't be 5 or 8. This can't be 5 or 8 here. That means the 9 is guaranteed to be here. 9 can only be with 2 or 4, so this cannot have a 1. Therefore, we know in box 9, 1 has to be one of these 2 digits. And none of these can be 1. So the 1 has to be with a 2. It could be 1, okay, so it could be 4, 7, and 1, 2. Or this is 1, 2. So this is 9 with 4 or 2. So the 1 has to be with the 2 here. So we have a 1 guaranteed in one of these 2 spots. If this is 1, that's 2. If this is 1, that has to be 2. So 2 is one of these, so this cannot be 2 here. So 2 has to be guaranteed here. This is 7. It could be with either 2 or 4. The 9... Okay, these... You cannot separate this from this. If you separate this from this, the problem is that this would have this domino would separate this from this, and they would be the same digit. So this has to be a combined domino here. Therefore, this is a combined domino. This must then be a combined domino because this is at least 9. This is 9 and has to be 4. So this is 4, which makes this 2. This can't be 2 or 4. This is 1. So this can't be 1 here. This can't be 2 here. 1 can only be with 1 and 3 as a domino. So 2 cannot be here. This is not 2. This is 7, which makes this 2. That means this can't be 7. This is 5. That can't be 5 or 7, so this is 4, which means this can't be 4 here. This must be 5 and 8 as a domino, because it must be a domino. because this adds up to that. So this is 5 and 8. These two must be dominoes. 1 has to be a domino here because it can't be with 4. Not red. Let's make it blue, I guess. So it's 1 and 3 here. This is 1 and 3. This cannot be 3. This cannot be 3. This can't be 2, 3, 5. So it's 6, 7, 9 as triplets here. This now must be a domino with those two. So actually we should have just made this orange, I guess. We'll make this blue. This is a domino. If it's 7, it has to be with 6. So one of these two is a 6. Okay, this can't be 2 because of the 2 in the row, or it's 2 in the column. We have a 1, 3. This can't be 1 or 3 left. Actually, what are the remaining digits? Are 2, 6, and 8. So they must be in dominoes with the ones above or the ones below them. This can't be 8 here, and it cannot be 5. This can no longer be 2. One of these is 6. It's either 6, 7 here, adding up to 13, or 3, 6, adding up to 9. So this cannot be 6 here. In fact, we knew that couldn't be 6 anyways, because this is an even digit. It must be paired with an odd digit. So 6 has to be one of these two, which means this can't be 6. This can't be 6, so this is 3, which makes that 6. That eliminates 3 and 6 here. This is 4, 5, 7, 9. So 4 and 5 are guaranteed to be here. Okay. You could have a single digit here, adding up with the sum, and then another digit. You can't have a single digit in this row. But if you had single digit here, sum, and single digit, it would have to be 9. Right? 9, 4, 5, because we guaranteed a 4 and 5 in that row. And this would have to be 9. But it can't be. So this must be domino here. So this is red, and we'll make this blue. That means this is domino here, because it cannot be separated. This has to be 13. Because if it's 9 and 9, it would be 4, 5, and what? 4 and 5. That's the only possibility, because it can't be 3, 6, can't be 1, 8, can't be 2, 7. And that doesn't work. So this has to be 4 and 9. Because that's the only one left. 4 has the only even digit here left, because this has to be a 6. We have a 2 and 8 here. This has to then be 4 with something. I guess it could be 4 and 7, actually. Whatever it is, actually, it could be 4 and 7. So this is 4 with 7 or 9. This is 7 or 9. Therefore, this must be a 5. And this is actually with a kid. It's 5 and 6 or 8. So we guarantee this. Interesting. This can't be 6 because of the 6 in the row. These are all odds. This has to be 5 and 6, 8 to add up to that. So each of these must go, well, the 1 actually has to go with one of these two. Right? No, the 1 could go up. It could go up with the 2, right? That's okay. So we're guaranteed that domino. 4, 7, and 9. Okay, what are the rest of the dominoes here? We have 13, 13, 11 or 13, we're not sure, 11 or 13. 13 or 9. This could be 9, 11, or 13. This is 9 or 11. Oh, the 7 means this can't be 7 here, so this can't be 2. Um, hmm. We have a, ooh, no, we don't. Okay, so this can never be 4-8 because we have a 4-5-8 pair here. If this is 4-8, that forces both of these to be 5, so this can't be 4. This must be 2 and 1 here. This is 8 and 4, so this is 11. 2 can be with 7 or 9. That works for either one. This can no longer be 8. This can't be 4. Since this can't be 4, this can't be 5 to add up to 9. This can't be 4. This could add up with this. If this were 5, that would guarantee this is 2. So then it would never add up with that. But it could add up that way. Rest of box 3 cannot contain 2 and 4 because one of these is 2 or 4 and one of these is 2 or 4. And the rest of the box... So 1 has to be one of these two. And it must be with a 3. Because it can't be with 2, because again, this is either 2 or 4, and one of these is 2 or 4. So the rest of the box cannot contain 2 or 4. And it must be as a domino with 3. So 3 then has to be one of these two. This 3 being here means this can't be 3. This is 6, this is 3. We have a 2-5, 2-5 pair in column 8, which eliminates 2 and 5 in the rest of the column. So this must be a 1-6 pair left, right? 1 and 6, 1 and 6. That leaves this as 6 can be with 5, 7, or cannot be with 3 in this case. So it's 5 or 7 to add up to 11. Okay, so this is 3, 5, or 7, 3, 5, or 7. 7 has to be one of these 3. 7 and 3 cannot be a domino together, so these must be a domino here. Therefore, this is a domino here, this is a domino here, and this is a domino here. It must be 7 and 4 to add up to 11, because it can't be 7 and 1. This must be then a 1. This cannot be 4. This is a 2-9 pair, which eliminates 2 and 9 in the rest of the box. This can't be 2. This must be 5 and 4, adding up to 9. This cannot be 5. This becomes a 3-7 pair here. That's a 1-6 pair here. So it's 6 and 7 and 1 and 3. 4 and 5 cannot be here. 2 and 9 are one of these two. This is 1 and 2. This cannot be 4. It's a 5-8 pair. Okay. How many of each do we have? I'm not really sure. Anyways, we have a 7-9, 7-9 pair in column 6. That eliminates 7 and 9 in the rest of the column. So this cannot be 7 or 9 here. This can't be a 3 anyways. So this 3 eliminates 3 here, which makes this a 3. So this is 3, this is 6. This cannot be 6 here. This can't be a 3 here. The 1 has to be with 2 or 3. And it cannot be with 2 because there's no 2 that's orthogonally connected to it. And this can't be 1 because of the 1 here. So this is 6. That makes this a 1. This must be a 1-3 domino here. So this is 1-3. I don't know, I'll mark it as red. This must be 6 and 7 as a domino here. We're green, I guess. This must be 6 and 7. Oops, not 6. 6 and 7, that makes this a 9. So 9 cannot be any of these. This 7 means this can't be 7. This is a 4-9 pair. That eliminates 4. That means this is 13, so this must be 5 and 8. That eliminates 8 here, so this is 5, this is 8. These digits cannot be 5 or 8. It cannot be 6, it's 4 and 7. 4 and 7 can't be here. This can't be 8, it's 5 and 6. We don't know how that fits, though. Okay. This 8 eliminates 8 here. The rest of column 3 has to be 1, 2, 4, 6, 7. 4 cannot be either of these. Where is the 4 in column 3? It must be here. So this is 4. Okay. This is necessarily different from that cell. And therefore, these can't be singletons. So this must be a domino here. And we know that's a domino. Actually, let's make that orange. Okay, how many dominoes do we have now? We don't know about these. This could be either 9 and 13 or 11 and 11. 1 and 3 could... Okay, 1 could be with 3 here or 2 here. We're not sure which. This adds up to either 3 or 9, because we have a single domino here. Or 4, but there's no 1, 3 possible here. So this is 3 or 9. We have a 3, 7, 9 triplet, actually. So this actually has to go here. We'll mark that as red. This guaranteed has to go here because it doesn't, there's no other domino. This has to go here. I guess we'll mark that as red also. So it could be 4, 5, 4, 7, or 4, 9. It cannot be 2 though. This adds up to a single digit. It's either 1, 2, or it's 2, 7 of the digits possible. So either way, this is 2. Which means this cannot be 2 here. So this is 9. This is 2. Again, we have a 3, 7, 9 triplet in row 3, which eliminates 3, 7, 9 in the rest of the row. This can't be 7 or 9. This can't be 7. These two digits add up to each other. It could be 1, 2, 4, 5, 6. What are the other possibilities in row 3? It's 1, 2, 5, 6, right? Yeah. Okay. What are the remaining digits in row 1? Sorry, row 2. No 4, 5, 9, or 2. So it's 1, 3, 6, 7, 8. Okay. Four with 5, 4 with 7, 4 with 9. 2, 7. Okay. How many of each domino do we have? We have 1, 2, 3s. We have 1, 2, 4s. We have 1, 2, 3, 4, 5, 6. Oh, we have a 1, 3 here and a 6, 7 here too. Huh. Okay. This cannot go up because these have to be a domino. So this must go down. So we know orange is not good there. Guess we have green. Okay. It's either 6, 7 or it's 1, 2. That's interesting. Or it could be 2, 7. How many 9s do we have? We have a decent amount of 9s, it feels. This is a 9, this is a 9, this is a 9. That's 3. This is 1, 3, or 6, 7, so that's not helpful. That's a 9. This is a 9. So 5, 6. This is a 9. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 nines. We have 1 9 left. Interesting. Just one, huh? Okay, this is 3 or 6 guaranteed here. It's either 3, 1 or it's 6, 7. This is 3 or 6. That means the rest of row 1 cannot contain a 3 or 6. So, okay, 7 cannot be here, so this is 2, which means this can't be 2. This 2 eliminates 2 here, so it's 5. This can't be 5 or 7, so it's 9. That 9 means this can't be 9 here, so it's 7. This cannot be 6 and 7, so this must be 3 and 1. 3 eliminates 3 here, so it's 9, which makes that a 7. So this can't be 7, this is 1, it must be with 2. This can't be 1 or 2, it's 6. We have all the 9s now, right? 1, 2, 3, 4, 5, 6, 7, 8. And where was the last one? 9. So we have 2 1/8s. We have a 2 2/7s, so that's 4. We have 3 3/6s. And we have 2 4/5s, I believe. Maybe not. Where's the last one? Oh, we have 3 3/6s. Okay. 4 3/6s, because one of these, this is 3 6. So 2 1/8s, 2 2/7s, 2 1/8s, 2 2/7s. That's 4. 4 3/6s, and 1 4/5. That means 7 cannot be here. 6 cannot be here. This becomes 1 3. That makes this a 2. So this is 2. This can't be 1. This is 6 and 7. That makes this a 3. That makes that a 6. 3 has to be one of these two. This is a 1 2 pair. That means this can't be 1 and this can't be 2. 9 cannot go down to the 6 8. And the 6 8 cannot go to the 6 8 here. So this must go down this way. That leaves these two as a domino. We cannot have 3 and 6. Also, we can't have a domino this way, because if it's this way, it's specifically 6 7 and 4 5. Because 4 must be with an odd digit, and it would be 4 and 5, but we have all 9 dominoes that add up to 9. So this has to go this way. We'll make that green and this one pink. So these dominoes are set. This is 11, 11. Okay, how many 11s do we have? I think a decent amount. This 2 eliminates 2 here, so this can't be 2. It's 1, which makes this 2. 1 must be with 3. Okay, what are the remaining digits in row 1? It's 1, 5, and 8. Okay. 9 can only be with 2 and 4 as a domino, so this must be a domino here. Four can't be here. 2 has to be here. Okay. This can't be 9 because of the 9 in the box, so this is 4, which makes that 9. 4 eliminates 4 here, so that's 7 and 4. 7 eliminates 7 here, so that's 3 and 7. 7. 3 has to be with 8. Or actually, it could be with 3. Okay, yeah, it cannot be with 6 because that adds up to 9. So this is 8. This can't be 8. This is 6. So this can't be 8 here or 3. This is a 1. That eliminates 1 and 8 here. So this must be a 5. 1 cannot be with 5. Therefore, 1 must be with 3 specifically. So it must go... let's make this pink and I guess this green. So this is a pair. This cannot be 1 or 5. This has to be 8. So this is 8. This is 3. This 5 eliminates 5 here, so it's 6 and 5. 1 eliminates 1 here, it's 8 and 1. And that should be the solution. I'm not sure if we have a correct amounts. Let's just check. How many 1, 2s do we have? We have 1 here, and 1 here. That's 3. How many 1, 3s do we have? We have 1 here, 1 here, 1 here, and 1 here. That's 4. How many 1, 8s do we have? We have 1 here, 1 here. So that's 2. So that counts for all the 1s. For the 2s, we already counted the 1, 2s. We have 3 2 7s, actually. Wait, that's too many, isn't it? That's too many. We have too many. The dominoes... Ooh. How is this the correct solution? Oh no, this is not a 2, 7 here. I just saw a 2 and 7 next to each other, and I was just like, oh yeah, start freaking. Okay. Yeah, this 2 goes with that 9, 2 goes with 1, 2 goes with 1, 2 goes... That goes with 2, 7. This does not go with that 7. It goes 2, 9. Okay, there we go. We have 2 2 7s, 3 2 1s, and the rest are 2 9s, I believe, right? 2 9, 2 9. So it should be 4 2 9s. We have 3 2, and it should be 4. 2 9 2 9 2 9, and 2 9. 4 2 9s. So that's 4 4 11 from 2s. And all the 1 2s are satisfied. 3s. We have 4 3 1s. We have a 3 1 here, 3 1 here, 3 1 here, and 3 1 here. That's 4. We have 4 3 8 6s. 3 6 3 6 3 6 3 6. That means we have 2 1 8s, 2 2 7s, and 4 3 6s. That's 2 plus 2 plus 4 is 8, plus a 4 5 adds up to 9 9s dominoes. So we have 4 3 6s, we have 4 3 1s, and we have 1 3 8. We have again 4 2 9s, and we have 1 3 8. So that's 5 11s. That means we need to look at 4 7s and 5 6s for the remaining 11s. So we have 5, we need 6 more. 4 7s. Let's look at 4s. We have 1, 2, 3. I think 3, right? So we have 5 plus 3, that's 8. So that means we should have 3 5 6s. 5 8 5 4. We have 1 5 6 here. 5 8 5 8 5 8 5. Another 5 6 here. 5 8 5 8. Wait, that's too few. Did I miscount? I probably miscounted. Okay, so again, 11s, 2 9s. We have 2 9, 2 9, 2 9, 2 9. This is 2 7, 2 2 2 9, 2 9, 2 9. This is 2 1, 2 9, 2 9. This is 2 1. This is 2 1. Okay. 4 3 8s. We have 1. Right? 3 1 3 6 3 1 3 1 3 6 3 6 3 1 3 6. 4s. 4 9. So we have 5 4 7 4 5 4 9 4 7 4 7. Okay, I miscounted. 4 9 4 7. Okay, there we go. That's 4. I had 3. and 4, 9. So I had 3, but that was wrong. So that's 9 total, and then we should have 2 5 6s. Well, 5 8, 5 6, 5 4, 5 8, 5 8, 5 8, 5 6, 2 5 6s, 5 8, and 5 8. Yep, okay. So all the 11s are accounted for. 13. We have to have 13 13s, and that should show the final ones. 4 9s. 4 9s. How many 4 9s? We have... actually, let's go from the 9s. 9 4, 9 2, 9 4, 9 2, 9 4, 9 2, 9 4, 3, 9 4, 4, 9 2, and this 9 doesn't count, so it's 4. 4 4 9s, 8 6s. So looking at 8s, 8 5, 8 1, 8 5. So we have, right, we're counting 13. So 8 5, 8 1 doesn't count, 8 5, 8 3, 8 another 8 5, 8 1, 8 5, 8 5, so that's 9, and 8 5, 10. So we have 10 13 so far. So it's then 7s and 6s. 7 2, so we need 3. 7 2, 7 4, 7 6, 7 4, 7 6, 7 6, 7 4, 7 2, and 7 4. Yep, that counts all of them. Okay, so this is correct. I miscounted earlier, and that's just wanted to make sure. Very cool, actually. Interesting exercise. The logic actually flowed very well throughout, and I guess I didn't really need to go that in depth about the numbers, but it still was good to see, right? I spent a lot of time trying to figure out the sums when I just actually had to figure out, hey, wait, what sets can this be, right? It's 1 2 3 6 and then 4 8, right? Because it cannot be a singleton here, because these would be the same digit, and therefore this must be a domino. So since this is a domino, it has to be 1 2, because it can't add up to 9. And everything sort of flowed from that, right? This was clever, though. Because we knew that was 3, that gave us this. This had to be 9. So we knew we had 3 and 9. And then you just try out all the possibilities for other sets, right? And you're given, you basically have to have, if you have 3 and 9 as the given sets, you're guaranteed to have 4, 11, and 13. So you could have gotten the sums that way, and that was much cleaner. Yeah. What can you do? Sometimes you go down the wrong path, but it is what it is. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.